Hey class, welcome back to Business Statistics. This is going to be the video on the binomial probability distribution. This is our next, our first discrete probability distribution that just wasn't the standard, list a bunch of x values and list their probabilities for their x values. Okay, so let's learn about this. We're going to learn a lot in this video, though I do think I'm going to try to keep it as concise as possible. But you're going to learn some Excel, you're going to learn how to use some binomial tables, you're going to learn how to compute some binomial stuff. So that's good. And you can bet that you're going to have a question very, very similar to this on the test. Okay, so this is an important one. Okay. The binomial probability distribution. So it helps to understand what a binomial experiment is first. So it has a fixed number of n trials, okay? So a number of trials with only two possible outcomes for each trial. So it's a binomial experiment. It is a binary experiment. There's either a success or there's a failure, okay? So it's like flipping a coin, right? It's on or off sort of thing. One trial cannot affect the outcome of the next trial. The probability has to remain constant from one trial to the next. Okay, and that's to say that each trial is independent. Okay, so the probability doesn't change from one trial to the next. So they're independent probabilities. So flipping a coin is a perfect example, right? You flip a coin, the chance of you getting a heads right now is 50%. If you flip 500 more coins on the 501st flip of the coin, your probability of getting a success on that trial is still 50%, right? Okay. And then x must represent the number of successes. Okay, so we use n to define the number of total trials and x to define the number of successes in the total number of trials. Okay, so here is our formula. The probability of x successes out of n trials during a binomial experiment is given by the following formula. The probability of x, p of x, is equal to n cx, so n choose x, which now this is that combination formula that we learned in the last module. So n choose x times the probability of success raised to the power of the success, right? So that's p raised to the power of x times the probability of failure raised to the power of the failures. So that's q raised to the power of n minus x. Okay, it's important to think about that. So n choose x is the number of ways that you can have x number of successes, okay? So it's the number of counting ways that you can have x number of successes. P to the x is the probability of successes raised to the number of successes, and q to the n minus x is the number of, or the probability of failures raised to the number of failures, okay? So that's the simplest way to think about the formula, because I know that the formula just looks bonkers, right? It looks scary. So that's that. All right. So yeah, Q is defined 1 minus P, or the probability of failure, just 1 minus the probability of success, sort of thing. And we define the mean as mu, which is equal to n times P. So that's the average, right? So the average number of successes in n trials is defined as mu, or the expected value, or the mean. But our formula is n times p, and then our formula for standard deviation is sigma is equal to n times p times q, all right, or n times p times 1 minus p. Okay, so those are things to write down on your companion worksheet. This might seem confusing to you. That's fine. Let's get into it, and let's see if we can figure some of this stuff out using an example, okay? As always, though, guys, if you have questions, please let me know that you have questions. I will answer those questions. Shoot the questions to the discussion board. Shoot them to me via email, whatever. We just want to get those answered. We want everybody to be in the know. We want everybody to be successful in this class, okay? So let's get into an example. The leading brand of dishwasher detergent has a 30% market share. A sample of 20 dishwasher detergent customers was taken. What is the probability that 10 of the 20 customers choose the leading brand? Okay, so it's not just 10 over 20. That's not the case, right? We're not assuming that it's just 10 over 20, like it's not just half, okay? This is a binomial experiment. We have n trials, and we have a 30% success rate, essentially. So the easiest way or the best way to go about this problem is kind of how we've been solving problems in other sections. We want to first list out what we know, okay, given the problem. So this sample of 20, so that is our number of trials, n. So we know that n equals 20 in this scenario, okay? And our market share we can believe is the success rate, because we kind of get that from if we read the first question. What is the probability that 10 of the 20 customers choose the leading brand? Okay, so this 30% market share we can assume is this is the probability of customers that choose the leading brand, our market share. Okay, so P is 0.3. So then what is Q? Well, we know that Q is just 1 minus P. So Q is just 0.7. Okay, so we have our N, we have our P, we have our Q, and X is going to just change with whatever problem we're trying to solve. So let's look at A. A is saying, what is the probability that 10 of the 20 customers choose the leading brand? Okay, so that's good. So X would be 10. So X being the number of successes. So this is just saying, okay, well, what is the probability that X is equal to 10? Okay, that's what we're trying to answer, but we have a formula for that, right? And so that formula is our N choose X times P to the X times Q to the N minus X. Okay, so I'm just going to put a little implies symbol, and then this would be implies that P of 10 is equal to 20 choose 10 times P, 0.3, choose 10 times 0.7, failures, the Q, to the 20 minus 10. Did I say choose 10? I meant raised to the power 10 when I said 3. So that's that. So that's our formula, right? So 20 choose 10, 0.3 to the 10th, and then it ends up being 0.7 to the 10th. Okay? So now on a test, if I gave you something where the numbers kind of blew up as much as they're going to blow up in this problem, what I mean by that is that this choose number gets pretty large, this 0.3 gets this 0.3 to the 10th gets pretty small, and this 0.7 to the 10th gets fairly small. If I asked you to just, do this on a test, I would be very clear about what I was asking you to do, and I'd say, oh, we'll just get to this point and complete the formula, okay? But I think on a test, I'm probably going to give you numbers where you can actually run the math comfortably, meaning it would be a choose value that's more of an 8 choose 3, and 0.3 to the 5, and 0.7 to the 3, something like that, okay? Okay, so, but here's what I want to do. I want to give you a couple of tools on how you can solve a problem like this, okay? So, we've got it in the correct form. We've thought about it correctly. Now let's go over to Excel and see if we can't calculate this in Excel. So, I just wrote combo, success, failure, and put a little box there for the sum. So, let's do each portion of this, okay? Let's do the choose portion, right? So, our combinations portion. So we want to do that 20 choose 10 formula. So you're learning a little Excel here as well. So we would go to the cell next to it, and we'd say equals combin of the number that you're going to choose from, 20, and the number that you're going to choose, so 20 comma 10. So this 184,756 is our number for 20 choose 10. Okay, and then we would just say equals 0.3 to the 10th. Okay, we get a really small number. And then this is 0.7 equals 0.7 to the 10th. Okay, equals that. And then we would just multiply all this together. So we'd say product of these three cells is that. Okay, so this is our this is our probability of exactly, so I'll say prob of exactly 10 successes in 20 trials for this specific problem. And when I say for this specific problem, I mean for specifically our probability of success being 0.3. Okay, so we get this number. So that was kind of a manual way to calculate this. It's like us, like doing a hand calculation, but actually just using Excel to do the hand calculation. Now, granted, on a test, you will not be able to use this, right? Because on a test, we're going to be using the Respondus Monitor and Lockdown browser, okay? So you are going to be having to do these with calculator, pen and pencil on a test. And I'll get you the details of that this weekend, I think, or early next week. But so this will be very, very helpful to you in terms of doing your chapter 4 and 5 quizzes, okay, knowing some of this stuff on Excel. The next way to do it, so this was like the manual Excel calculation where we piece together the formula. Another easier way, I would say, is just using the binomial function within Excel. So you just can go ahead and say equals binom.dist, okay, equals binom.dist. And it asks you for the number of S, which is the number of successes, which we know is 10, comma, the number of trials, which is 20, right? The probability of success, which we defined as 0.3, and then whether or not we're talking about a cumulative probability, okay? And I'll just tell you we're not talking about a cumulative probability because we want to know what the probability of X equaling 10 is, not the probability of X equaling or of X being less than or equal to 10. That's what cumulative refers to. Cumulative is going to refer to everything leading up to that point and that point, okay? So we would just say 0 for this. That's Excel language for false, okay? 0 and 1 are Excel language for false. So our formula is going to look like that, okay? We just hit enter and hopefully we get the same number. Boom. Perfect. So we get the exact same number there, okay? All right, so that's that. Now, another way that we can go about solving this, okay, that you more than likely will be able to use on a test, okay, are the probability tables, okay, and you'll definitely be able to use these like in your homework or in your quizzes and whatnot, okay. So there's this, yes. So you log into your class, okay, and you would go to Content and Resources, if you haven't already been here. So you click Resources, and then you go to Probability Tables. Okay, so these are the probability tables for the whole course. You need those for the whole course, and they look like, oops, excuse me. Pull this into the screen. They look like this. All right. Okay, they're going to look like that. Binomial, Poisson, area under the standard normal curve. Those are the things that we're going to use for this first portion of the or of this early portion of the course for the most part. So the way that we go about doing this is we would have to find our binomial table that is, so notice that we have a lot of different tables here for binomial tables. We have to first find the correct table, okay, and the correct table is going to be the one that corresponds to our number of trials. Okay, so like look here, we have n values up here in the corner. So this is a binomial experiment where n equals 2, where n equals 3, n equals 4, n equals 5. So we got to go find our n equals 20 binomial table. It's right here. Okay, once we found our correct table, then we have to find what our p-value is. Okay, so in our problem it was 0.3. So we would go over here to our p-value of 0.3. Boom, there it is. Then, if we wanted to find the probability that we're looking for, we have to go down and we have to find our number of successes. So we have probability of 0.3. Now, here's our x, our number of successes. So we go scroll down to 10. And we want to go where they intersect. 0.0308. Okay? So now we go back. What did we get? 0.0308 when we hand calculated it. 0.0308 when we used the Excel version. And now we've got 0.0308 in our table. So multiple ways to figure out these values. These tables are really, really nice when it comes to doing cumulative probabilities. And so I guarantee you will use something like this on the test, okay, in terms of doing cumulative probabilities. Because if I asked you the question, and I'm about to ask you that question, I think it's in B, of what is the probability of getting at most 10, you'd then say, oh, well, I have this nice little table here. So I can have the probability of x equals 0, 0.0008. Probability of x equal 1, 0.0068. Probability of x equal 2, 0.0278. And you just add up this whole column here. And like that's that. That's your probability. Okay? So we'll use that. Let's look here. Okay, so B. Oh, here you go. What is the probability that 10 or fewer customers choose the leading brand? Okay? So for B, and hear me out here, we don't use, well, I guess you could. Geez, that would be miserable. But we don't use this formula, right? You could use this formula if you wanted to. But you would be using this formula for x equals 0, x equals 0, x equal 1, x equal 2, x equal 3, x equal 4, all the way up through x equal 10, this big formula, and you'd be adding them all up. Okay, so that's clearly not the way you want to approach that. I mean, it would take you legitimately like an hour to solve the problem, okay? So you don't want to do that. So here's a couple ways to do it, right? So you wouldn't even use this hand calculation method, right, that I talked to you about. One, you could use an Excel way. So this is if you're doing it on a quiz or just in a project or something like that. Okay, so not a test. You're not going to be able to access Excel in a test. But so you could do this here. The only thing that we would do differently is when it asks for cumulative in our formula, we would just say, yes, it is cumulative. So we just put in a 1. Okay, now it changes it. What this is doing is adding up all of the probabilities, okay, that are before 10 and 10 as well. Okay, so we can do it that way. I also mentioned, yeah, you can use your table. So we pull up our table, and we want to add all these 0 through 10 up. So these values. Luckily, I came prepared. And we have all those values right here in Excel. Okay, so here's our Excel. We add all these up. Let's see what we get. So now I'm just showing you kind of the manual way to do it using the table. 0.9828. So this is rounding to 4 digits, right? Because everything in the table is 4 digits. But look. We're pretty darn close here. Looks like the exact version is more like 0.9829, but that's fine. That's just rounding error from this table. Okay? So yeah, that's that. So there is another way to do the cumulative. Okay? So please, 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 please let me know if you have questions on this, guys. I want to help. I know that this stuff can feel a little overwhelming. I know that these formulas are scary. I know that. I get it. I've been there. Okay? So, but we are here to help. I'm gonna do my best to get you guys where you need to go. Okay. And then lastly, let's just do C. C is very, very easy. What is the average or expected number of customers that will buy the leading brand? So average, that's our keyword for our mean. So C is just asking, well, what's our mean? So our average number is just going to be our N times P. So our N, which is 20, times our P, which is 0.3. So that would be 6. So that would be the value that we would expect to see, right? Now what is the standard deviation? Well, standard deviation, we know formula for is just the square root of NPQ. Okay, and that's just going to be square root of 20 times 0.3 times 0.7. And that is equal to 2.05, roughly 2.05. There's a bunch of decimals, but that's about it. All right, guys, like I said, let me know if you have questions. Let's get through this together. Communication. I know I always harp on it, but that is okay. Let me know if you have questions. What did I say? Discussion board, email, peers, other online resources, just whatever we got, videos, slides. Let's get you where you need to go. Yeah, that's that. So until next time, the Poisson video will be next. All right, thanks so much.